Hi guys, welcome to Skill 5, Multiplying and Dividing Rational Expressions. Yesterday, or the last lesson, was simplifying rational expressions, so now we're just going to work on the multiplying and dividing. So if we remember, rational expressions means a polynomial divided by a polynomial. If we were normally just to multiply a fraction, because technically this is a rational expression, if I were to give you guys this to multiply, you would just do 1 times 3 over 2 times 7, or just 3 over 14. If I gave you guys something like 1 times 2 over 2 times 7, you just do 2 times 1 over 2 times 7. You could simplify that there, and it just becomes 1/7. So what we're going to do today is not that different than this concept here. So we're going to start with multiplying. So just like what we did, I would multiply everything in the numerator. I'm just going to focus on the numerator first. I can combine like terms. Then I'm going to multiply everything in the denominator. So I have my constants, my b's, my x's. And now this goes back to simplifying. This looks like what we did yesterday where we simplified, or let's go forward where we simplified monomials. So 15 and 18, I can divide both those, divide by 3. I get 5 and 6. If I have 2 x's on the top and 4 on the bottom, I end up with 2 on the bottom. 5 b's on the top, 2 b's on the bottom, I end up with 3 on top. Go ahead, pause your screen, do this one down here. Remember, multiply straight across the numerator and straight across the denominator. So you're pausing your screen and doing that one down. Okay, so we should have gotten, our answer should have been 8 over 5b. So this is similar to that, where I'm multiplying rational expressions, or rational expressions made up of linear expressions. So now I have this plus and minus. I'm going to kind of treat this like factors or groups, and I'm going to see if I can factor the numerator any further. So I have a 5, 8x, and 56. Their greatest common factor is going to be an 8. I can pull a 2 out of 2x and 14. So now I'm going to rewrite this. I want you guys to pause this, and I want you guys to try to simplify this the rest of the way. So you're pausing this, try to simplify this the rest of the way on your own. So once we multiplied our constants, we should have gotten 40x plus 7 over 18. X plus 7, our x plus 7's factor out or divide out to become a 1. Then just have 40 over 18, which is 20 divided by 9. So just like when we were simplifying, we had to sometimes factor. So hopefully we're getting better with factoring by now. This is our basic chart. If it's 2, 3, or 4 terms, the first thing we're always going to do is look for the greatest common factor, or the GCF. So we need to factor the numerator and the denominator are all linear factors. So that's what we're going to start doing now. So if we look at this, I'm going to treat everything as a factor. Can I factor x plus 1 anymore? I cannot, or x minus 1. So that is what it is. This is 3 terms. So this is A, B, C. I'm going to do my ACB tree. A times C is 6. Add to my B of -5. -3 and -2. I'd plot an x. I'd plot a -2. and this would factor to this. So I like to mark, I factored that, I factored that. I want you guys to try to factor the denominator, both of these on your own. So go ahead and factor both of the denominators on your own. Okay, so once we do that, we end up with x minus 1, x minus 1, or sorry, we end up with this 3x minus 1 here, and A, B, C were identified there, so I did my ACB tree. And now my denominator looks like this. So I'm going to use different colors just for simplicity's sake. I can factor out an x minus 3, an x minus 1, and x minus 1. And then whatever I have remaining in the numerator and the denominator is what is left. So I have an x minus 2, an x plus 1, and a 3. So this is really similar to what we did yesterday, because when we multiply, we just treat all of these as little factors and see if we need to factor further. So you guys, we're going to go on to slide 7. So I'm going to go ahead and start you guys on slide 7, and you guys will finish this one on your own. I'm going to help us factor. Remember, we have to factor each of these. I'm going to factor, or help us factor this first one. So my A times C is negative 28. No, not negative 28. Negative 42. And then my B is 1. So I want what two numbers multiply to negative 48 but add to positive 1, and that's going to be negative 6 and 7. So then I'd have 14x squared minus 6x plus 7x minus 3. I can pull out a 2 and an x from this first one, and I end up with a 7x minus 3. Ooh. And all that we can pull out of this one is a positive 1. So when I do that, when I pull out a positive 1, I end up with 7x minus 3. So I have 2x plus 1 times 7x minus 3. Okay, so we factored this one. I want you to go through and factor the other 3. So what we end up here with is this part became this x plus 2 becomes, or x minus 2 stays as x minus 2. This factors to this, for 49x squared minus 9 factors to that. Once I'm to this point, I see what I can cancel out. Those reduce to 1, and these reduce to 1. So then what I'm left with is a 2x plus 1 in the numerator and a 7x plus 3 in the denominator. Okay, so I want us to think through how we would normally divide fractions if I gave you 1/2 divided by 1/4. We would turn the division into multiplication by multiplying by the reciprocal of the second term. So 1 times 4 is 4. And now this multiplication is like what we just did. So if I gave you 1 over x times, or divided by 1 over y, we can turn it into multiplication by keeping the first the same, the first term the same, the multiplication the division becomes multiplication, and then we multiply by the reciprocal of the second term. So we want to keep this in mind as we start these next ones. I'll do the first one with this, and then you guys can do the second. So this is equal to if we multiply by the reciprocal of the second term. So I'm going to first turn this into multiplication. So my 3y is now in the numerator. And then you can show this in as many or as few steps as you need. And this now becomes like what we've been doing. And this is equal to I can divide both of these by 9. Or not 9. Sorry. I can divide both of these by 15. And that will get me 3/4. And then I have 1y on the bottom, and both of my a's cancel out. So I want you guys to try this one down here on your own. So remember, you're going to write this as something times something, and then one term, and then simplify it. Okay, so go ahead and pause your screen and work on that. Okay, so once we turned the division into multiplication, this is what we ended up with. Then we can multiply across the numerators and across the denominators. Then we simplified our 30/36. Both of these can be divided by 6, divide by 6. And our x's, if I had 4 in the numerator and 1 in the denominator, that simplifies just to 3 x's in the numerator. Okay, so this is similar to what we've been doing. We just have more terms now. So I still want to write this as something times something. I'm going to take time to reduce each of these at a time. I cannot reduce x plus 8 anymore. So these are all linear. These have a 5. I can pull out, make this become an x plus 8. So this is, oh, that's going to be in the numerator though. Because we multiplied it. This I can pull out a 2. And this is, I can pull out a 4. And then we have 36 divided by 4. So if we wrote this as, I have 4/10. These two divide to 1. Those two divide to 1. And my 4/8, both of those can be divided by 2, and I end up with 5/5.